I'm Tom Holland. I'm from the University of St Andrews in Scotland. Aaron Quigley, Professor Aaron Quigley is my supervisor. And I'm going to talk very briefly about a paper which is MobARDoc, which is Mobile Augmented Printed Documents. So I've kept it fairly short and fairly who, what, why, where, when type thing. So what we're looking at doing is, so the idea is printed documents, digital documents, and the divide between them. And we'll hear lots of it today, I'm fairly sure, about adding digital features to printed content, be that annotations, be that textual search, textual copies, a whole slew of things we want to add to these printed documents. Obviously, we're specifically looking at smartphones. So the higher end of stuff, iPhone, Android phones, Nexus 1 and so forth. So not quite the mainstream yet, but we're not trying to do it on laptops or webcams, we're trying to do it specifically on the smartphone, which has a whole host of problems. So we're telling them documents, but we're going to include things like books, newspapers, magazines, as well as academic documents, business documents. So not just something you print out on a printer, something you can buy in a bookshop today. Okay, so why, again, you probably all know why, but there's a lot of talk at the moment about going all digital, so the iPad, Kindle, all these different ways of consuming stuff digitally, but we're still reading books. I finished this last night. I still like buying printed books. I still like reading them that way. And if I can interact with them digitally, but not without having to read it on the screen, I still prefer doing it. And I should be a real candidate for buying an iPad, but I like books still. Why do you stick with paper? Sounds silly, but well, it's cheap, easy to use, it's been around for quite a long time, provable. It's actually sustainable, ironically. Because we can plant new trees fairly easily, paper's going to be around for a while. It's kind of one of the odd things about paper, and it lasts a long time, strangely enough. Anyway, so again, I'm sure lots of people we all get why paper's going to stick around. Eventually, potentially, the Star Trek future will all be using pads and everything will be great, but 10, 20, 30 years, how long until paper finally dies out? Could be a while. Anyway, running out of time. So basically what we're doing is we're combining a series of existing techniques, adapting them and then adding some new ones in. And the idea is we want to match a digital original, so PDF, with what we can see through a camera phone. So in terms of PDFs, we use a mixture of, with locally printed content, we have something which gathers it when you print it. And then the idea being if you're going to apply this commercially right now, you would deal with the publishing houses and get PDFs from them of the content, which you would then index. We're using, to actually turn the PDF into something useful, we're using a commercial tool called PDF-LibTeX, which is a text extraction toolkit. Basically, puts in the PDF and it'll spit out an XML document for each page, which contains X and Y of each word and what the word text is. Very handy if you want to start indexing stuff without having to write your own engine. For something which doesn't have a PDF and has never had a PDF, something before PDF was invented, you can generate a PDF by old-fashioned OCR-based techniques. Okay, so what we're trying to do isn't OCR. You've already heard about locally likely arrangement hashing, LLAH. So matching the pattern against an original source material, and then using that to determine what you can actually see through the camera. So you're not actually trying to recognise characters, you're purely recognising the pattern of words, which has its own problems in the fact that it's less unique than, say, doing OCR, but it's much faster. This is also limited using the current techniques that we're using to languages which use variable width words with space-separated content. So Western-style languages. For languages, China and Japan, we struggle because of the kind of composure of the content is different. But for most Western languages, we all have a similar sort of pattern we can use. Okay, so basically with a mobile device, we're looking at extracting this pattern from the camera view, matching against the document profile, so the original digital content matching against that, and then being able to overlay an interface. Sorry, I've got a very old laptop and the battery's not very well anymore. Power save best we can. Okay, so being able to overlay that interface in real time on the mobile device with the content you're seeing, and then being able to interact with that and add new content and see additional digital content. So kind of other things which we're doing, which some of the reviewers commented on, the existing work, which say recognising, I think it's 10,000 pages, using a webcam and a laptop, isn't very scalable realistically. You expand to every document in the world, both now, future and past, you're going to basically the search space becomes too large. So we're going to use existing markers fairly easy. I've got a few more minutes. So we're going to use existing markers to try and cut down this space. So to recognise the document, things like we can leverage existing barcoding technology on books, magazines, newspapers to recognise the document. And then for locally printed content, we have an existing system we published a couple of years ago. Basically, when you print something with your printer, we have a special adapter for cups, the Common Units printing system, which as you print something, grabs the content, generates a PDF, fires it off to a server, and then sticks a barcode as an additional page in the printout. So we're not touching the original content, we're leaving the words intact, no additional markers, but we're adding one as a new page so you can recognise the document. And this is to cut down the search space. Trying to do it in real time is difficult enough on a mobile phone without having to search a very large number of documents. You want to have to be able to search a very small subset because you've got very limited processing power. Yes, that. Yeah, so mobile optimised image processing, this is the difficulty with it all. A lot of existing techniques, even non-OCR ones, are very intensive. Like the locally likely arrangement hashing aren't currently suitable for a mobile device. Some of the existing stuff, what they tend to do is take the image from the camera phone, send it off to a server, where you can chuck lots of processing power at it, and then fire the results back to the phone. So we're trying to do it purely on the phone itself, which basically means chucking away the rulebook with a lot of existing stuff, binarisation techniques. A lot of them expect you to loop through several times all the pixels. So we're kind of avoiding processing, we're going to try processing as little data as possible to hopefully, which is actually less accurate than current techniques, but it's faster. That's the whole point of it really. So stripping away what we don't need to make it faster, but suitable for what we're going to do. So I'll shut up now. Right, so I'm here, see what you're all doing, and also hopefully chat to some of you and get some feedback on how I'm planning to evaluate this. Apart from the human-centred, do a series of experiments with users, I want to grab some measurable data, mathematical type data, and it's actually quite difficult to do when you're trying to do it with a phone, gathering real data with a large number of documents. So hopefully I'll have a chat to some of you later. Any questions now if I've over in time massively?
Thank you, Tom. Thank you. So we've got time for